In this video, we're going to cover instantaneous velocity. Sometimes the average velocity is all we need to know about an object's motion. So, for example, a race along a straight line is really a competition to see whose average velocity is the greatest. The prize goes to the competitor who can cover the displacement in the shortest amount of time. But the average velocity of a moving object can't tell us how fast the object moves at any given point during the time interval delta t. Average velocity is defined as the change in position over the change in time. This tells us the average velocity for a given length or a span of time. If we want to know the speed or velocity of an object at a specific point in time, so for example with this radar gun, we want to know the instantaneous velocity. Watch what happens when we look for the instantaneous velocity by reducing the amount of time we take to measure displacement. So in this example, we have an object that travels at a constant velocity. Find the magnitude of the velocity using the data above. Hopefully you found 10 meters per second. What happens if we measure the distance traveled in the same experiment for only 1 second? What is the velocity? That's right, it's 10 meters per second. What happens if we measure the distance traveled in the same experiment for a really small time interval? What is the velocity? It's 10 meters per second. So since we need time to measure velocity, we can't know the exact velocity at a particular time. But if we imagine a really small value of time and the distance traveled, then we can estimate the instantaneous velocity. Okay, so what this really means is, if you're dividing by t, and t goes to 0 because you need an instantaneous delta t, in other words, delta t is 0, you can't find it. Okay, but we can actually make the time and the distance so small that it ends up giving us that instantaneous value. To describe the motion in greater detail, we need to define the velocity at any specific instant of time or specific point along the path. Such a velocity is called instantaneous velocity. Note that the word instant has somewhat different meaning in physics than in everyday language. Instant is not necessarily something that is finished quickly. We may use the phrase, "it lasted just an instant," to refer to something that lasted for a very short time interval. In physics, an instant has no duration at all. It refers to a single value of time. One of the most common examples we can use to understand instantaneous velocity is driving a car and taking a quick look at the speedometer. At that time, we see the instantaneous value of the velocity. The instantaneous velocity is the same as the magnitude of the average velocity as the time interval becomes very, very short. So as delta t goes to 0, we can then solve for the instantaneous velocity. And remember, velocity is a vector quantity, so it needs to be delta v with a vector sign and delta x with a vector sign. The graph below shows velocity versus time. How do you know the velocity is constant? Go ahead and write your answer down now. Okay, so let's take a look at the answer. Here, the y value, which is the velocity, remains constant as the time progresses. So as you see, for each time interval, 1 second, 2 seconds, 3 seconds, the velocity remains constant. If this is indeed velocity, though, we need to have a vector on top, and we need to give it a direction. Now, this is the interesting thing. Notice that I use I hat. Okay? Now you may be thinking, well, wait a minute, isn't that the vertical axis? Yes, it is. But look at what we're plotting on the vertical axis. We're not plotting y, we're plotting velocity. So what does it mean if I'm above the x-axis for the y variable? It just means I'm going in a positive direction, and in this case, I've chosen east. What if I drew this line below the x-axis? That's right, it would mean that we were going west. So you have to be careful when it comes to graphing vector quantities. Being vertical doesn't mean y direction, j hat. It can mean positive direction versus negative direction below the x-axis. The graph below shows a velocity versus time graph. When is the velocity increasing? When is it decreasing? When is it constant? If you need more time, go ahead and pause. Okay, so let's take a look at this. When is my velocity increasing? It's increasing when the slope of the line is positive. When is it constant? That's right, when the slope of the line is 0. When is it decreasing? Now, this is a tricky question because look right here. In this region right here, it is decreasing. But what happens when I cross that x-axis? I go from a 0 velocity to a negative velocity, which means I'm just going in the opposite direction. So once I cross that x-axis, I start speeding up again. Okay? So when is the velocity increasing? It's increasing here and also here. When is it decreasing? It's decreasing here. When is it constant? Right here and right here. Use the graph to determine the average velocity of A. Okay, if you need more time, you know what to do. Okay, go ahead and let's look at the answer. It says only A, so I'm going to assume we're only going to do it for A for right now. It has a constant velocity of 1 meter per second, and the average velocity is also 1 meter per second. Okay, use the graph to determine the average velocity for picture B. Now notice it gives you some time intervals, and there's a reason for this. When we're talking about average velocity, we don't want the slope of the line to change. Otherwise, it becomes a little more complicated. Okay, so from 0 to 1 second, which is right from here to here, what is your average velocity? From 1 to 3 seconds. Okay, now they are getting a little tricky on you. Oh, I'm sorry, 1 to 3 seconds is from here to here. Okay, from 3 to 4 seconds. From 4 to 5 seconds. And from, okay, now this is tricky, from 3 to 5 seconds, from here to here. Okay, go ahead and pause the video so that you can go ahead and calculate these values. Let's take a look at the answers. From 0 to 1 second, it's 2 meters per second. Let's do this. Okay. There. Okay. From 0 to 1 second from here to here, notice we have 4, right? It's 4 meters per second to start with. It's 0 meters per second here. Okay? So for the 1 second, we have to take this and divide it in half because we want the average value. So you take 4 plus 0 divided by 2, and that gives you 2 meters per second because that's how you find an average. You add the two values together and divide by 2. Okay, from 1 to 3 seconds, we can see that it is 4 meters per second because it's constant. From 3 to 4 seconds, notice that we're going from 4 to 0. So in this case, we're going from, we're going to take 4 plus 0 divided by 2, and that gives us 2 meters per second. The problem is from 3 to 4, it says that it is a positive or a plus 2 meters per second because we are above the x-axis. Okay, so from 4 to 5 seconds, we're going from 0 to 4, but it's actually negative 4. So negative 4 plus 0 is negative 4 divided by 2. Divided by 2, there's two numbers, and that gives us negative 2 meters per second. Keep in mind that all of these should have an I hat at the end. We're talking about velocities, And if you don't have a direction here, notice they put a plus sign here, but none here and none here. That doesn't make any sense. So you always have to have the I-hats. Okay, so from 3 to 5 seconds from here to here, we're going from 4 to negative 4. So what's 4 plus negative 4? 0. 0 divided by 2 is 0 meters per second. Okay, use the graph to determine the instantaneous velocity of A at 2 seconds. Okay, so let's take a look at the answer. You should have 1 meter per second. Why? Because it's not changing. Okay, and again, if this is a velocity, it should have vector signs. And let's give it an I-hat because it's in the plus region. Okay, use the graph to determine the instantaneous velocity in picture B at 2 seconds. Okay, let's take a look at the answer. It should be plus 4 meters per second, and again, we're going to give it a vector sign, and we're going to make the direction I-hat not plus. These graphs show a constant velocity and B a varying velocity. Moving the velocity, when the velocity of an object is constant, the instantaneous velocity is the average value. When the velocity of a moving object changes, its instantaneous velocity is different from the average velocity. In the next video, we're going to talk about acceleration.